Hi everyone. Statistics is often thought of as the process of answering questions but with incomplete information. A question is posed, data is collected pertaining to the question, and then based upon that data, the question is answered. The tool that's used is often connected to the type of data that's collected. So it's very important when you read a problem in statistics to understand what type of data are you working with. There are two primary types of data, qualitative and quantitative. Qualitative data deals with descriptions or descriptive numbers. The data can be observed, but it cannot be measured. Different examples of qualitative data include colors, textures, smells, tastes, appearance, perceptions of beauty, perceptions of effectiveness, things that are all descriptors. Ratings are, as I notice I have that highlighted in red on this slide, are a particular form of qualitative data. They sort of straddle both areas, qualitative and quantitative. Note that the root word of qualitative is quality. That's where it gets its name. Qualitative data describes the quality of the data. Other names for qualitative data are categorical data or nominal data. Nominal meaning named, categorical meaning the data falls into categories. Another type of qualitative data, just an example, would be with election season appearing this coming year, polling data. Who are you going to vote for? If someone asks you who you're going to vote for, you would name an individual whom you're going to vote for. So the data would then consist of a list of names. This person is going to vote for candidate X or candidate Y or candidate Z. So whoever they're voting for, that is the data. The other big category of data is called quantitative data. Quantitative data deals strictly with numbers, but particular types of numbers that can be measured. There are numbers that are actually qualitative, for example, a zip code. A zip code is a number, but it's not something that's measured. Basically, what a zip code does is it describes a location, so it's qualitative. So just because data is a number doesn't mean it's quantitative. Data that can be measured are quantitative, so lengths, heights, areas, volumes, weights, speeds, times, temperature, humidity, sound levels, cost, members, ages, test scores. Anything that's measured is quantitative. And again, the root word of quantitative, as you see here, is quantity. Now, there is so as I mentioned on the previous slide, ratings are qualitative, so they're a special type of qualitative data. So basically ratings are called ordinal data. And ordinal, the root word of ordinal, is ordered. So ordinal data are categorical values that possess some kind of order. So for example, at the end of this course, you're going to have a chance to rate your instructor. And he is either very poor, average, good, or very good. So those are categories, but they're not things that you can't place them anywhere on a scale. They're basically very poor means is less good than poor. Poor is less good than average. Average is less good than good. So in other words, very poor would be the least of these ordered categories. Very good would be the best of these ordered categories. Numbers are sometimes attached to the ratings. So for example, when you fill out your course evaluation, what you're going to do is you're going to say it'll say basically rate your instructor. A 1 is very poor, a 2 is poor, 3 is average, and so on. So again, what you do is you give the instructor a rating, and the ratings correspond to some sort of description. Basically 3 is an average, or 5 is very good, and so forth. When presented as numbers, ordinal data is not considered quantitative because of two reasons. The first is subjectivity. Quantitative data, if you're a height, for example, everyone who is the same height is that same height. Everyone who's 5'8" is 5'8". There is no variation there. But what one person considers an average, a 3, might be the same in terms of quality of instruction, for example, that another person considers to be good. So a 3 for one person is maybe a 4 for another, or maybe a 2 for another. So there's an element of subjectivity. The other reason that ordinal data is not considered quantitative is because the differences are not uniform. Meaning, a 1, basically, I often have people when they talk about ratings, they say, well, I never give, someone has to be outstanding to receive the highest rating. So there's a wide gulf between, say, a 5 and a 4, but 3s and 4s may be very close together in the person's mind. So in other words, the difference between a 5 and the 4 is not uniform as the difference between a 4 and a 3 or a 3 and a 2. Here's a few examples. In oil painting, you can collect quote-unquote qualitative data about this oil painting. Its color, it has a red, basically it's red and green, gold frame. The smell, the texture, if you look at, for example, some of the old masters, the texture of the color, you could actually see the very broad brushstrokes describing the scene, or the, basically different qualities you can describe. You could also talk about this painting quantitatively. So quantitative would be, for example, the dimensions of the picture, of the frame, of the weight of the picture, of the surface area, of the cost. Another example would be if you go to Starbucks and get a latte. You can talk about the aroma. Is it robust? Is it, I don't know, different aromas. I'm not a coffee drinker. Earthy would be maybe perhaps another aroma. The appearance, frothy, or does it lack froth? The taste, the type of cup that it's in, whether it has cinnamon or not on the top. Those are all qualitative qualities. So the type of topping of a latte would be a qualitative variable. On the other hand, you can also talk about the quantitative variables for this latte. The size, is it 12 ounces or 16 ounces or 6 ounces? The serving temperature, the dimensions of the cup, the cost, and so forth. So here's a picture. Let's make one qualitative observation about the picture. So, for example, the river is flooded. That would be a quality of this scene. The river has different states. This is true of, say, for example, the Ohio River in Kentucky. The Ohio River may be at flood stage, it may be below flood stage, or almost at flood stage. Those aren't measurements, although you can talk about measurements, talk about the height of the river. That would be quantitative. But in this case, a qualitative description would be the river is at flood stage. A quantitative observation, and I was thinking about this when I was creating these slides, the number of cans tied to the station wagon, the just married station wagon. So as someone is married, if they have cans tied to their wagon, we could collect data on weddings. This couple has 15 cans tied. The couple in the picture has, it looks like 5 cans tied. Those are quantities with respect to the number of cans tied to the rear bumper of that station wagon. We're going to finish up this video with basically a homework-like problem. In 2002, Consumer Reports published an article evaluating refrigerators, lists 41 models giving the brand, cost, size, and different variables about each of these models. List and categorize each of the variables in this situation. Okay, so the brand would be for example, Whirlpool or GE is qualitative, nominal. The cost in dollars would be quantitative. Size in cubic feet would be quantitative. The type, freezer on top or freezer on bottom, would be qualitative nominal. Estimated annual energy cost would be quantitative. Customer satisfaction, and it lists there poor, average, good, etc. That would be qualitative ordinal because it's a rating of each of these models. The types of repairs that are typically needed in the first 5 years of the refrigerator, that would be, for example, does the compressor malfunction, does the ice maker malfunction? That would be qualitative. The number of repairs needed during a typical 5-year period would be quantitative. So there are just an overview of different types of data that we will address in this course.